Hey, welcome back to your favorite calculus class. We're going to look at indefinite integrals and the substitution method. Specifically, this section is going to split into a couple parts: pattern recognition as well as change of variables. Both techniques involve u substitution, which we've introduced previously, but we'll examine more and some more examples today. So if you remember with the old chain rule, if you had the derivative of some composite function, f of g of x, and you'd get the f prime, right, of g of x, g prime of x. I just want to use it with a lowercase there. So if you were to integrate that f prime, g of x, g prime of x, then it'd take you right back to your original, right? It'd undo that, if you will. So when we're doing our u substitutions, we're trying to set it up so that it's in that form with that composite function. So we need to recognize the inside function and then the derivative of that inside function. So for example, let's say we have this, and I know you could expand this and run the integral power, the power rule for integration, but let's do it with u substitution instead and see if we can recognize the pattern here. So what we're going to do is we're going to let u be, and we're going to let it be this x squared plus 1 portion, and we're going to see if this will work out for us. So now we're going to take the derivative with respect to x, so du dx is 2x, derivative of x squared, of course the derivative of 1 is 0. So in other words, if I take dx to the other side, du is 2x dx. So to make the replacement, if this part becomes my u, I'll have u squared, and then to have du in there, I need to have a 2x dx to make the substitution in for du, and you notice there's our du, right? So this is that's our f prime, g of x, there's our g prime of x. Okay, there's our f of g of x, there's our g prime of x, if you will. Okay, so again, we make the substitution. U is the x squared plus 1, so u is squared. And then there's our 2x dx, which is our du. Now we can integrate that. And this is just an indefinite integral, so make sure you throw in the constant. So u to the third over 3, and then put the u back in. So u is x squared plus 1. So x squared plus 1 to the third over 3 plus our constant there. Okay, so that's the pattern recognition. Of course, if you're taking an integral and you have a constant there, you can put that constant out in front there. That'll help you when you're working some problems. And by the way, I should go back on this a little bit. If you're not sure who u is, just try something. For example, on this same problem, if you had done this and you had let u be the 2x, so du dx is 2, so you have 2 dx, and you're like, well, that doesn't really help me because what am I going to do with this? So you got to let u be that inside piece, right? So it's kind of a trial and error with these. You're just kind of playing around with them initially. So I'm going to work with that x squared plus 1. Let's see how it works on this one. Again, let's let u be x squared plus 1. This is a similar handle here. So du dx would be 2x. Take the dx to the other side. So du equals 2x dx. So this will be you'll have u squared. But the problem is we need 2x dx. Well, I have an x dx, but I need 2x dx. Right? I'm missing a 2, so I'm going to put a 2 in, which means I got to offset it. Right? It's just a constant, so we can do that. And you notice there's our 2x dx, so we can make the replacement with du. So the 1/2 stays on the outside. I have u squared, and then I have, here's my 2x dx, there's my du. So 1/2, now I run the integration, u to the third over 3 plus a constant, put the u back in, u is x squared plus 1, so we got 1/2 x squared plus 1 to the third over 3 plus a constant. Take that half through, so you got x squared plus 1 to the third over 6. Half times a constant, still a constant. So you got a sixth x squared plus 1 to the third power. All right, how about this one here? We got the 2x minus 1. So we're going to say, well, the inside part, let's work with that. Let's let u be that 2x minus 1 inside part underneath the radical. Let's see if this will work for us. So du dx is 2. I'm going to take the dx to the other side. So du, I need 2 dx. All right. So here's my u. I'll have the square root of u, but the problem is I need 2 dx. So again, I can throw in a 2. So I have 2 dx, but then I got to offset it with 1/2. All right, so we have 1/2. Here's our 2 dx. There's our du. We have square root of u, or u to the 1/2. Now we can go ahead and integrate that. So u to the 1/2 plus 1, so u to the 3/2, all over 3/2, in other words, times 2/3, keep change flip, plus our constant, distribute that, and we've got 1/3 u, which is 2x minus 1 to the 3/2 plus a constant. So there's some guidelines for making a change of variables there that we kind of went through. There's just the general power rule for integration right there, but we're just going to do the u substitution, so we're just going to make it real clean and simple there. Just get my thing here. Let's work some more with the substitution, the general power rule. We're going to let u be that 3x minus 1. So that du is 3 dx, because notice we have 3 dx. So this ends up being, so here's our du, and then the u is 3x minus 1. So the u is to the fourth, and I have the du, so this is no issues here. We can go ahead and integrate. So put the u back in, 3x minus 1, the fifth over 5 plus our constant. Okay, let's do that next one there. So notice again on this one, we could expand this, we could FOIL it and run a power rule, and you'd notice you'll end up with the same thing. But I'm looking at this, I'm like, gosh, if I let u be that x squared plus x, then du is 2x plus 1 dx, and I have 2x plus 1 dx. So there's my du, and then there's my what I let be u. So it's just u du, which is u to the 3/2 all over 3/2, in other words, times 2/3 plus a constant. Again, put the u back in. Oops, that's x squared plus x, 3/2 plus a constant. All right, lastly here with this x cubed minus 2, let's let u be that underneath the radical there. Because then when I take du dx, I'll get 3x squared, which again, I have it perfectly right there. So this becomes square root of u, or u to the 1/2, and then du. Here's my du part, right? So we got u to the, oh my gosh, I just realized I did this up here. Why'd I do that? This is just u to the 1 power. Sorry, guys. That's u squared over 2 plus a constant. So we got x squared plus x. squared over 2 plus the constant. Sorry about that. I noticed that because this is u to the 3 halves all over 3 halves. So. All right. Let's do some more here. Whoops, there's our solutions here. All right, how about this one here? We got negative 4x dx on this one. All over, I'm sorry, negative 4x dx, and then it's over 1 minus 2x squared. So what we're going to do, a lot of the times if you've got a ratio, a lot of the times it's that bottom that ends up being your u. So du is derivative 1 constant, derivative negative 2x squared, negative 4x dx, and you're like, there's our du. There's our du. And then here's our u, so it's 1 over u squared. In other words, u to the negative 2 du. So when we integrate that, it'll be negative 2 plus 1, so u to the negative 1 over negative 1 plus a constant, which ends up being negative 1 over u plus a constant, which ends up being negative 1 over 1 minus 2x squared plus a constant. Okay. All right, let's do the next one here. We got cosine squared sine of x. Now, if I let u be sine of x, the problem is if I let u be the sine of x, which a lot of, that might be your hunch initially, I get cosine x dx. But the problem is I have two of these cosines, right? I have cosine squared, I have a cosine times a cosine. So that's not going to work for me. I'm going to have to, oops, let u be, let's let u be, let's let u, that's a u, be the cosine squared on this. And let's see if that'll get us anywhere. Cosine squared x. So du dx would be 2 cosine x, and then to the 1 power, chain rule, derivative of the cosine, negative sine. You're probably looking at this like, well, here's my u, but now I got too much for my du. I can't just add in negative 2 cosine, right? Like this is the part I'm missing in here for my du. So that's not going to work either. I'm just kind of running you through your thought processes on this as you're kind of working through these u substitutions. So you're like, well, let me try something else. What if we just let our u be, instead of cosine squared, how about if it's just cosine? Because I know the derivative du dx is negative sine, dx to the other side. All right, how would this work? So then I would have, this is u squared, and then I need negative sine x dx. Well, here's sine x dx. I'm just missing a negative, so I'll put a negative in there, offset it with a negative out front. So negative sine x dx, there's my du. And now I can run it. Put the u back in, cosine cubed x. So negative cosine cubed x over 3 plus our constant. Okay. All right, how about this one here where we got the sine of 2t plus 1? A similar approach on this thing is you're thinking, well, let's let the u be, I've got a ratio, so let's let it be the denominator, but I'm not going to let it be cosine squared. I'm just going to let it be cosine of 2t plus 1. So let's let u be that denominator, but not squared, just cosine 2t plus 1. And you'll see that when we take this derivative, which is the negative sine 2t plus 1, don't forget chain rule, you're taking the derivative, so you got to take the derivative 2t plus 1, which is just 2. So this du is negative 2 sine 2t plus 1 dt. Okay. So I need a negative 2 sine 2t plus 1. So I need a negative 2. I'm going to put a negative 2 in. I'm going to offset it with a negative 1/2. There's my du. That's my du part. And then on the bottom, since u is cosine 2t plus 1, I just have a u squared on the bottom there. So this becomes negative 1/2, stays out front. This is 1 over u squared. In other words, u to the negative 2 and du. And then we run the integration. Run the integration. Negative 2 plus 1 is a negative 1. So we got negative 1/2. This is negative 1 over u to the 1. And our u is cosine 2t plus 1. It's a constant. So we got 1 over 2 cosine 2t plus 1 plus a constant. Okay. All right, how about this next one here? If we let's let your initial hunch would be, well, let's let it be the stuff underneath the radical, might be your hunch. So you'd have 2x dx. Well, the problem is I have x cubed. I can't add in x squared and offset it, right? We can't do that because it's not a constant. So that's not an option for us. We're going to have to be a little bit creative on this one. Let me erase all this one. Let's go ahead and let our u be, so let's try something else. Let's let it be the, well, let's do the x squared plus 1, because if we let it be x cubed, then our du would be 3x squared dx. And that's a problem because I can't, there's nothing I can do with this radical, right? So again, I've got issues, and in that case, actually more. So back to the problem, let's just let u be, whoops, let me get my, let's let u be x squared plus 1. And let's see what we can do with this if I've got 2x dx. So this would be the square root of u. I have one, I could throw in a 2 and offset it, but I'm still short. I have x cubed, and I only have one x right here, 2x dx, right? So I'm short x squared. But if I look at this right here, look at this. Isn't x squared the same thing as u minus 1? So if I could rewrite this as 1/2, we put this, I put the 2 in, I have x cubed, so x times x squared, and then square root x squared plus 1 dx, all right? So here's our 2x dx. There's our du, that's no problem. And then this, here's the square root of u, so u to the 1/2. And no issues with that, but that x squared, oops, not that big. This x squared, what do we do with? Well, we take this, because I have an x squared in it, and we solve for x squared, so it becomes u minus 1. And then I can distribute this. So I got a half u to the 3/2 minus u to the 1/2 du. And sure enough, we can finish this out. So u to the 5/2 over 5/2, u to the 3/2 over 3/2. That's our constant. Distribute that through. We got 1/5 u to the 5 halves minus, again, we're distributing this, right? Minus a third u to the 3 halves. Okay, good problem there. Good problem there. So, sometimes you might have to really think about it, make some change of variables there and some substitutions. Finally, this last slide is just showing you a few more integration formulas, the integration of the tangents, the natural log, the opposite value of secant of x, and so on. So 4 more of those, keep those in mind. So thanks for listening. We will see you next time.